A rectangular plate of side A and B is suspended from a ceiling by two parallel strings of length L each figure. The separation between the strings is D. The plate is displaced slightly in its plane, keeping the strings tight. Show that it will execute simple harmonic motion. Fine. Now let's say it is displaced to left hand side by a small distance, right? And this is the position. Alright, the springs will get in this orientation. Let's say this angle be theta, so this angle will also be theta. Alright, now a restoring force will start acting on the block, and mg will be downward. So the restoring force that is toward the mean position will be equal to mg sine of theta, because this angle is theta, right? So the restoring force will be equal to mg sine of theta. This restoring force can be equated as m into acceleration. So mass is cancelled from both sides. Acceleration comes out as g sine theta. Now since it is given that the plate is displaced slightly in its plane, keeping the strings tight. Now if the springs are tight in all the situations, then the angle theta is very small. Fine. So the sine theta will be almost equal to theta. So g sine theta can be replaced by theta, that is equal to acceleration, and the value of theta will be equal to, let's say this is my displacement x and this is the spring length. So sine theta can be written as x by L, that is the acceleration. So again, the acceleration is directly proportional to x, so the coefficient of x can be compared to omega square, so that is equals to g by L. So the time period comes out as 2 pi under root of L by g. That is the answer.